In this video, I'm going to be talking about steps to a digital signature using a carrier pigeon. Okay, so step 1, you have the sender of the data, in this example, Sam. Step 2, you have the receiver of the data, in this example, Rick. Step 3, Sam has a small text document that he wants to send to Rick. Step 4, Sam has a want to send this text document in a way that guarantees security. Step 5, Sam wants to guarantee that the document came from him, authenticity. Step 6, Sam wants to guarantee that the document was not altered in transit, integrity. Step 7, Rick wants all the same things that Sam wants. Step 8, Sam downloads GPG, GNU Privacy Guard. Step 9, Sam creates a GPG key. Step 10, Sam creates a GPG private key. Step 11, Sam hashes the document using the terminal and GPG. Step 12. Come on, step 12. Come on, piece of shit. Step 12. Now Sam has his plaintext paper and the paper hash of the plaintext paper. Step 13. Now Sam encrypts his hash document using his PGP private key, but not the plaintext document. Okay? Mistyped here. Step 14. Sam prints out his plaintext document. Step 15. Sam prints out the encrypted hash of his document. Step 16. Sam puts both pieces of paper into a tiny case. Step 17. Sam ties that tiny case to a carrier pigeon. Step 18. Sam sends that carrier pigeon to Rick. Alan, the adversary, commits a man-in-the-middle attack. Alan sees the pigeon leave Sam's house. Alan captures the pigeon. Alan reads Sam's plaintext message. Alan destroys both the plaintext message and the encrypted hash message. Alan creates his own plaintext message and encrypted hash message using his private key. Alan sends the pigeon to Rick's house. Rick, the receiver, receives the carrier pigeon but can't decrypt the hash. Rick takes the message off the pigeon. Step 2, Rick reads the plaintext message. Rick then decrypts the encrypted hash message using Sam's public key. Rick can't decrypt the hash because it's a message encrypted with Alan's private key and not Sam's private key, and therefore cannot be decrypted with Sam's public key. Rick, the receiver, receives the carrier pigeon but can't verify the hash. Rick takes the message off the pigeon. Rick reads the plaintext message. Rick then decrypts the encrypted hash message using Sam's public key. Rick then hashes the plaintext message himself. Rick then compares the hash of the plaintext to the decrypted hash and what's been sent to him. The hash that he has created is the same as the hash he has created, then the file is secure. So basically what that means, as far as I understand it, is that Rick got a pigeon, right? He got a pigeon with two pieces of paper. One's the plaintext saying whatever, and one's the hash of the plaintext, right? And so what Rick does is Rick hashes. So Rick and Sam are going to have like SHA-256 as an agreed upon hashing algorithm. Rick will hash Sam's plaintext document, and I think that if Rick gets the same as Sam, then the message is somehow secure. So I think that's how it works. But this is just a little experiment that I made, and I hope that people like it. And if you like it, like, comment, share, and subscribe.